I guess here are the notes that we all started on August 23rd, Monday. Some of us did not get finished with them, so if you are either absent and getting caught up, if you want to get ahead and get the rest of the notes done, or if you maybe had a squirrel moment and whoop, missed something, here are the notes. I'm going to go pretty quickly. Please make sure that you pause and rewind. Whenever I'm plotting points, I know where they are. I've done it a million times, so please pause, plot the points on your own before you allow the video to move on. First things first, with translations, with all transformations in general, we're going to talk about this pre-image and image. Your pre-image is the OG. This is the image before anything happens to it, before any transformation. Okay, this is your original. Okay, this is the original figure. Your image is going to be the image after. This is your new image. After you're completely done, this is your final product. Rigid. This is a word that we're going to need to make sure that we understand. Rigid is going to go with congruent. What happens is whenever you have a geometric figure, no matter how whatever transformation, in order for it to be rigid, the pre-image and the image must be congruent. Well, let's remember what congruent is. Congruent means same shape and same size. So in order for a transformation to be rigid, it has to preserve congruency. The pre-image and image must be congruent. Talking about translation. Big thing with translation is we are sliding, we're shifting. Every single point of this figure is going to go the same direction, the same distance. So the way I always remind students is you got the SL in translation and you have the SL in slide. Translation slide. Everything moves the same direction, the same amounts. With translation does preserve that congruency. There's your rigid. So translation is a rigid motion. Okay? Your first example. Translation nothing changes with translation between 8th grade math and geometry. So we're going to go pretty quickly here. When we go left on our coordinate, or when we go left with a figure, we're messing with our x coordinates. Okay? So our x is going to move when we go left. 6. When we go up, we're going to go with our y coordinate. That's what's going to be changed here. So we go back, when we write, basically this is part of what we call our rule. Okay, this is the second half of it. What's going to happen is left 6 means x is going to, when we go left, we're going towards our negatives, so we're going to subtract 6. With our y, think about the y-axis. When you go up, you're going towards the positives. So we're going to add 8. Okay? So we've got these 5 points here, A, B, C, D, and E. What we're going to do is we're going to apply this rule of subtracting 6 from the x and adding 8 to the y. And we're going to come up with our A through E prime, our image points. So here's our pre-image already here. So what that means is we're going to take our x coordinates. So here on A, 2, we're going to subtract 6. And then on our y, over here, as we see, we're going to add 8. So what ends up happening is our A prime, we're going to take 2 minus 6. We're going to wind up with a negative 4. When we take negative 3, we add the 8 to the y. We're going to wind up with a positive 5. So there's our A prime. So we could come over here, we could plot 1, 2, 3, 4, 1, 2, 3, 4, 5, maybe a place that you need to pause and plot yourself. Make sure that when we label this, we label it with that prime apostrophe so we know which is the OG, pre-image, and which is the image. B, same thing. We're going to subtract 6 from the x, so 2 minus 6. Hey, guess what, guys? We just did it. Just go, hey, look, we got a negative 4. Well, it's not going to change. It's the same exact equation, 2 minus 6. So just grab it from up here. No need to calculate it again if we already have it in our work. So then we have our negative 8. We're going to add 8. Well, a negative 8 plus an 8, they're going to cancel. And we're going to get a 0. Bada bing. C to C prime. Take that 8x. What are we doing with x? We're subtracting 6. So let's subtract 6. Not too bad of a problem, right? 8 minus 6. We're going to wind up with positive 2. Then we have that negative 8, and our y, we're adding 8. So we have, again, just like we did up here with B, they're going to cancel out. We're going to get another 0. And I know I didn't plot those. We'll plot those in just a moment. Point D, again, subtract 6 from the x, minus 6. Oh, we just did that. What did we get? We got 2. We have that negative 3. We're going to add 8. You know what? I remember seeing that earlier. Look up here. We had negative 3 plus 8. What did we get? We ended up with a 5. So we're going to have 5. So negative 3 plus 8 gives us 5. Point E to E prime. Our x-coordinate 5, we're going to subtract 6. 5 minus 6, we should get a negative 1. And then our y-coordinate of negative 5, we're going to add 8. So 5 plus 8, we're going to get a positive 3. So go ahead and pause. Get point B prime through through E prime on there and connect them in alphabetical order. And we should have this exact figure. Then you will press resume and you will see that you'll have the exact same thing as me. So I'm going to go ahead and just get them on here real quick since I already know where they go. So now that you've got it done, you should see here, yours should match mine. We've had the exact same size, exact same shape. We've just shifted it to the left 6 and up 8. The next problem, we are now going to write in the ordered pair translation. All we're saying here is we want to write the rule. Okay? So when translating, other than just adding and subtracting like I just did, you can actually physically move the point. I call them little jumps. And so that's what you're going to see here. We're going to have to figure out from A to B, from figure A to figure B, okay, A being pre-image, B being image. What did we do? How did we move? Now our rules are going to start off with x comma y, saying your x and your y coordinates, and the arrow here says your x and your y coordinate are going to do this, and that's where we're going to write in that plus and minus from our x's and our y's. So the first thing we need to focus on is find your pre-image. Start there. A. I don't care which point you start with. It does not matter. What matters is when you go to your image, you have to go to the corresponding or matching point. So here, I always recommend go left and right first. I'm going to use the top right corner. I'm going to go from the top right corner to the top right corner. So I'm going to go left and right first. I like to kind of shade here to see where to stop counting. And I'm going to move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I went right 10, which tells me whenever I go right on the x, I'm going to add. So here I'm going to take x and I'm going to add 10. Then, no use in going back to the original. Just start right here where you left off and keep moving. Now you're going to go down 1, 2, 3, 4, 5. So we went down 5. And on your y, when you go down, it's subtraction. So we have y minus 5. So there's your entire rule. xy is going to do x plus 10, y minus 5. Next, we're going to go from B to D. I'm just going to use the same exact point, that top right here. And I know that I want to go left or right first. So I need to make sure that I meet up with where this point is. So I'm going to go I'm going to go right 1, 2. So I went right 2, which is adding. So I'm going to go xy is going to go to x right, so right 2 plus 2. And then I'm going to go down 1, 2, 3, 4, 5, 6. Down 6 is going to be subtracting from your y, so y minus 6. Now we're going to go from D to C. Be very careful we don't go C to D. We're starting here at figure D. That's your pre-image. We're going to move over to C. I'm going to switch points here, okay? So we're going to write our rule in x, y is going to turn to. I'm going to start at this top left. And I'm going to go left and right first. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 to get in line with that top left over here. Long way, right? This time we went left 12. So since we went left, that's going to be a subtraction, x minus 12. Then all we need to do is go down 1. Make sure I stay on the screen here. Down 1, so that means minus on your y. So we have y minus 1. Okay, and that's how we're going to write the rule from pre-image to image. Next, let's take a look at, now this problem, example number 3, I'm not going to lie. With my classes to save time, I didn't worry about number 3 or 4 because we're not going to be dealing with three-dimensional shapes right now. So we're just going to focus on taking these points and just applying this transformation again. What I suggest is go ahead, we're going to pause. Pause the video, plot A, B, C, and D, and I suggest that you go ahead and you translate each point 4 units right and 3 units up, and then put your A prime, B prime, C prime, D prime. Connect them all together, connect A, B, C, and D in alphabetical order, and then get your primes connected in alphabetical order. I'm going to plot the points, and then I want you to plot them as well, but I'm going to pause it, and so the next thing you're going to see is going to be. So after you have plotted, this is what you should have. Now again, we're going to go ahead, and if you'd like to just do the adding and subtracting from the rule, because we're going to write the rule, you may go ahead and do that. Or if you'd like to do the little jumps, you can do that as well. So we're going to go up, right, we're going to go 4 units right for each one. So I'm just going to count 1, 2, 3, 4, and it says 3 units up. 1, 2, 3, and there's my A prime. B, we're going to go 1, 2, 3, 4 to the right, 1, 2, 3 up, there's B prime. Make sure we're putting that prime mark. C, 4 to the right, 1, 2, 3, 4, 3 up, 1, 2, 3. There's C prime. D, 1, 2, 3, 4 to the right, 1, 2, 3 up, there's your D prime. We connect them in alphabetical order, and we should see the exact same figure. It's just translated slid up and over. So when we take our rule, we have XY is going to become, well, here, 4 units right, that's going to be our X. Since we're going right, this will be positive. So we're going to take our X and we're going to add that 4. Sorry, not in parentheses yet. And then with our Y, which will be the up, this will be Y. And up is going to be adding, so we're going to do Y plus 3, and there's our rule for that. The next two will go real quickly. Okay, I really highly suggest you pause it and try this on your own. Example 4 is exactly like we did on example 1. We're just going to take the coordinates and we're going to subtract the 2 and add the 4. Okay, so we're going to take point A at 2, 3, and we're going to figure out what A prime is going to be. So in order to do that, we want to make sure that we're subtracting 2 from the X. And we're going to add 4 to the Y. So here we have 2 minus 2, whoop, 0. 3 plus 4, we have some nice ones here. Look at that, 7. Ladies and gentlemen, we're done with example number 4. Done! Sometimes it's that easy, guys. That quick and that easy. Number 6, I don't know what happened to example 5. I don't know. Probably deleted it because I didn't like it. We are now going to figure out what the rule is so that we can apply it to another figure or another point. So here we have a translation, moves B onto B prime. Okay, so we're going to use these to figure out what the rule is, and they want to know what is the image, the C prime of here's C, but we want to use that same rule. So let's take a look at how to do this. Let's go ahead and write out B at -1, 4. We have a little bit of room here, and I'm going to look at B prime. B prime is at 0. Let me move that over a little bit so it's a little bit lined up a little bit better. Prime, we're at 0, -6. So you have to ask yourself, okay, X coordinate. When we went from B to B prime, how did I get from -1 to 0? And we answer that saying we have to add 1. So we know that in our rule, we're going to take X and we're going to add 1. So let's take a look at Y. We're going from be careful here, a +4 all the way to a -6. So we have a long way to go. How did we get there? We had to go from a positive to a negative, so we know it's subtraction. And we end up subtracting 10. So we're going to wind up with our rule of Y minus 10. So we're going to go ahead and take C, -2, -5. And we're going to do exactly what we just did in the example above, this guy right here, okay? And what we did number 1. We're going to take that rule. It says add 1 to the X, so I'm going to add 1 to the X. So subtract 10 from the Y. So let's perform those to get C prime. -2, we're going to add 1, getting closer to the positive, so we're going to add 1 to the -2. We're going to get -1. We have a -5, we're subtracting 10 more, so we're going even further into the negatives, and we're going to get -15. All right? Reflections. Only one little part's going to be new on this, but here we already have here a reminder that pre-image is before the transformation, image is after the transformation. A reflection is going to be a transformation across a line of symmetry. What I want you guys to write above that is line of reflection. Okay, oops, helps if I can spell. Your line of reflection is normally what we call this. Okay, your reflection is also known as a flip. We're going to flip across a line of reflection. You can remember that FL in flip and the FL in reflection. Okay, can't see the FL very much in my flip, but you see it. And it's just going to be a mirror image. Your reflection does preserve congruency, so your reflection is going to be another rigid motion. So we're going to have rigid in there again. Jumping straight through it, x-axis. Let's reflect over the x-axis. A couple ways you could do this. First thing is you can actually find that line of reflection, move to it, go to the other side. Here we want to make sure we highlight in the instructions what we're reflecting over. If you're going to move the points physically, you're then going to want to highlight the line of reflection. Here, your x-axis. So what we need to do is we need to figure out we're the same distance from the mirror as our reflection is from the mirror on the other side. So we need to move point A to that line of reflection, then start counting over again to that exact same number. What I mean by that is if we move to the line of reflection for point A, we're going to go 1, 2, 3, 4. So we move 4 spots. So now we need to start over and count to 4 again on the other side of that line of reflection. 1, 2, 3, 4. And there is our A prime. Making sure that we're putting that prime mark. Okay? B, I notice I'm moving 1, 2 to the line of reflection. So I need to move 2 more. Start counting again, 2 more on the other side. And there's B prime. C, we're going to go 1, 2, 3, 4, 5, 6, 7. So I need to count and start over again, count 7 more on the other side. 1, 2, 3, 4, 5, 6, 7. So I suggest you do is pause the video and figure out the coordinates and write them in. We're going to make a comparison here. So now that you've done that, you've paused it, right? We're going to find out that the coordinates of A prime are going to be -3, -4. -3, -4. B prime is going to wind up at 4, -2 over here. C prime is going to wind up at +3, -7. What are the coordinates of point x, y after reflection of the x-axis? Well, this is the rule, ladies and gentlemen. Your x, y is what's going to happen to it. Well, let's take a look. What did you notice here? You should see something going on. Your x's did not change. What axis you reflect over, don't touch that coordinate. It stays the exact same. What ends up happening is your opposite coordinate will go to the opposite sign. So your y coordinate, how we note that, don't touch x. X is going to stay the same. But what we want to do is we want to change the y. And we note that with a negative in front of it. What I need you to understand, it does not mean change it negative. If you have a negative already and you put a negative in front of it, negative and negative make a positive. So what this is you're changing the sign of the opposite coordinate. Okay, opposite coordinate changes to the opposite sign. Same thing with your y-axis. We take a look here. We have our y-axis. That's going to be right here. I want you to pause it because I'm going to move very, very quickly on this. Go ahead and move to the y-axis. Do the exact same thing we just did. X, I'm moving 2 spots, so I'm going to go 2 more. And I have x prime. Y, I'm going to move 1, 2, 3, 4, 5, 6. I'm going to go 6 more. 1, 2, 3, 4, 5, 6. There's my y prime. Z, I go 1, 2, 2 more. 1, 2. And there's z prime. Connect these together. We should have a perfect reflection where if I fold my paper over that line of reflection, they should lay right on top of each other perfectly. Here we're going to find out that our coordinates of x prime are going to be -2, +4. Y prime are going to be -6, +2. And z prime are going to be -2, -5. Again, we're going to see that difference for our rule. We're going to see now the x changed signs. Notice I did not say turn negative. Yes, it did, but we're looking at the opposite coordinate takes the opposite sign. Y-axis, opposite coordinate, takes the opposite sign. Okay, so we'll have negative x, or change the sign of the x, and then we have y. So here again, this is the one that's changing. All right? Next, we have reflecting across y equals x. This is an equation of a line, okay? Your y equals mx plus b. We do not have a b. Our y-intercept is 0. What we do, it's 0. So all it is it's just a positive slope of a rise of run over 1, 1, 1. Up 1 over 1, up 1 over 1. Perfectly, okay? Because we have a positive x, so it's a positive slope. I'm going to go and let you guys know here, counting is not going to be fun. What you're going to want to do is know the rule. Because counting sometimes, if you look at S, you have to go 1 and a half. You've got to remember to go a half and a 1, and it gets really confusing. So here, I'm going to give you the coordinates, and we're going to see what happened. Your R is going to wind up at 6, negative 4. Sorry, your R prime. Got that one in there. So we're going to wind up at 6, negative 4. Here's your R prime. Your S prime is going to wind up at 2, negative 1. 2, negative 1. There's your S prime. Your T prime is going to wind up at negative 1, negative 6. So we're going to go negative 1, negative 6. This will be your T prime. So again, if I fold over that line of reflection, this will lay exactly on top of each other. Okay? Congruent, rigid. Now, what do we notice with our coordinates here? What happened between negative 4, 6, 6, negative 4? Oh my gosh, all we did was switch the two coordinates around. Look at this. Negative 1, 2, 2, negative 1. All we did was switch them. Negative 6, negative 1, negative 1, negative 6. Switched. So your rule here is going to be your x, y coordinates. All you're doing is you're switching them to y, x. Take them, switch them around. That's all you have to do for that. Now, when we come across your numbers, x equals negative 1, what we need to remember is something in algebra, and we'll talk about it again later on in the year, your VUX and HOI. For the next two, we want to remember VUX and we want to remember HOI. All right? So, with our VUX, we remember VUX, V, U, X. If you have a vertical line, your slope is undefined, and your x is going to equal a number. Sorry, there should be a number sign. X equals a number. So here we see that x is going to equal a number. So we are going to have a vertical line. So what we need to do is we need to go to negative 1 on the x. So we go to negative 1 and just kind of put a little point there. Vertical, remember we should talk about our pre-assessment. Vertical is going to go up and down. So what we need to do is we need to create a line that goes through, up and down vertically, that negative 1 on x. So here is our line of reflection. With these, there's not really a rule, so just count. Do the counting I showed you. What I like about this is the line of reflection goes through the shape. So some of the points are going to go one direction while other points go a different direction. So take a look at A. It takes me 1, 2 to get to that line of reflection, so I'm going to go 1, 2 to the other side. Here's A prime. B, I'm going to go 1, 2, 3, 4, 5 to the line of reflection. I'm going to go 5 more. 1, 2, 3, 4, 5. Here's B prime. C, we're going to go 1, 2, 3, 4. And we're going to go 4 more. 1, 2, 3, 4. Here's C prime. Now what you need to be careful of, going to connect these. When you're going to find the coordinates over here, you need to make sure that you are starting back here at the origin. Don't get confused with this line. Start back at the origin. A is going to be at positive 1, 1, 2, 3, 4, positive 4. So we're at A prime is at positive 1, positive 4. B prime, start back at the origin. B prime's over here. We're going to go negative 1, 2, 3, 4. Sorry, I lost count. Negative 1, 2, 3, 4, 5, 6, positive 2. Negative 6, positive 2. C prime, up here, we're going to go negative 1, 2, 3, 4, 5, positive 1, 2, 3, 4, 5, 6, 7. So negative 5, positive 7. There is no rule to go along with this. Okay, no easy rule to memorize like the other ones. So just play it like this with actually moving it. That's going to be the easiest way. Now with example number 5, you have y equals a number. So this is where we're going to remember HOI. If you have a horizontal line, you have a 0 slope, and y is going to equal a number. So that's what we have. So we're going to have a horizontal line here. So we're going to go where y equals positive 5, so on our y-axis, 1, 2, 3, 4, 5. This is the line of reflection right here. I always like to extend it a little bit. Always a good idea to get that highlighted so we can see where we need to stop counting and start over again. All right. I'm going to find myself going 1 to get there. So I'm going to go 1 on the other side. There's A prime. B, I see I'm going 1, 2, 3. So I need to start over on the other side. 1, 2, 3. Oop, right on top of the C. B prime. Point C, we're going 1, 2 to the line of reflection. Start counting over again, going past it. 1, 2. Here's C prime. We connect those. Now it's harder to see this way when they overlap, but now we need to come up with our coordinates. A prime. Okay, again, always start here at the origin. A prime right here, we're going to be at negative 1, 2, 3. So we're at negative 3, positive 1, 2, 3, 4, 5. And there's stuff that I'll talk to you guys about here in a moment about one thing that is in common with all of these. B prime, all the way up here, we're at positive 1, 2, 3, 4. Positive 1, 2, 3, 4, 5, 6, 7, 8. So positive 4, positive 8. C prime, last one, right here. Back to the origin, 1, 2, 3, 1, 2, 3. So we're at positive 3, positive 3. Let's go back and look at the x equals our VUX, our vertical line. What I want you to notice here is that when we are reflecting over x equals a number, our VUX, our vertical line of x equals a number, I want you to notice that the opposite coordinate stays the same. Okay? So the opposite's going to stay the same on that one. Again, this can get a little tricky here. We're doing a y equals a number, so our x is going to stay the same. Easiest for these two is just don't worry about a rule, just find the line, draw it in, count to the line, start over and count that many on the other side. And there you go for our reflection and translation notes.